Back, we're ready to do section 2. So let's talk about periodic table and classifying the elements. So we have an ID picture, but we also have some other information on our driver's license, like our height, our weight, our address, eye color, and it helps to identify us if it's ever needed. What information can we get off the periodic table similar to an ID? Well, it usually displays the symbols, sometimes the name, sometimes not. It does also tell us things about like its atomic number, its atomic mass for the average atomic mass. And it can sometimes give us other information. So here's one that's similar to what I give you on your test. However, I do not include the electrons in each energy level on your periodic table. So it does have the symbol, in this case aluminum, and it has a name, has atomic number, and has the average atomic mass for that element. So again, I don't give you the electron configurations. I think you can figure it out by looking at the periodic table. So, symbol for aluminum is printed in black. That means that it is a solid at room temperature. It has other colors for other elements. Your periodic table does not give us this information that I give you on your test. But most of the elements are solids at room temperature. The symbols that are in red are gases at room temperature, and most of those you should already know, like nitrogen, oxygen. Fluorine and chlorine might be unusual for you to know, but then the noble gases, I think the group name kind of gives it away that those are all gases at room temperature. And there are two liquids that are elements that are liquids at room temperature, and you should know those two, and those are mercury and bromine. The symbols that are grayed out are elements that are not found in nature or they are man-made. So, talking about group names, you have a certain number of group names you need to know. Group 1A is called the alkali metals. Group 2A is the alkaline earth metals. The other names I need you to know would be halogen. It comes from the Greek word meaning salt former. And so it is, the halogens make salts with groups 1 and 2. And you look in your book, the atomic number and mass for the element silver. And you should be able to tell us what those are. And it should be Ag. Atomic number is 47, and atomic mass is 107.87. Electron configurations. Luckily for us, everything in the same group has the same ending configuration. So if it's in group 1, it ends with 1s electron. But the number out in front will change from 1s to 2s to 3s as you go down, because it'll be in a different row of the periodic table. So, electrons play a key role in determining the properties of elements. So there should be some connection between the element's electron configuration and its location on the periodic table, because that's how they react. Elements can be sorted into noble gases. You need to know that name. Representative elements. You need to understand what those are, and that's group. That's the S block and the P block. It does not include the D or the F block. Transition metals, which is the D block, and the intertransition metals, you need to know that name as well, and that's the F block. And you should understand their electron configurations. Another family or group that I want you to know is the noble gases. Helium, neon, argon, krypton are examples of noble gases. That is group 8A on the periodic table. These are nonmetals, and they are called inert gases or noble gases because they do not react or take part in reaction. Xenon is one exception, but we have to work really hard to get it to react. So, electron configurations for the noble gases always have the complete shell filled. There is a difference, however, between helium, neon, argon, and krypton in that the number or the row of the periodic table is increasing, and helium doesn't have any p electrons, but it still has a full electron configuration or shell. The S and P sublevels are completely filled with electrons, 2 electrons in the S sublevel and 6 electrons in the P sublevel. An exception with that would be, of course, helium, which doesn't have a P block to fill. What can we learn about each element in the periodic table? Well, you can learn the element's name, its symbol, atomic number, average atomic mass, the number of electrons in the energy sublevel, and each energy level. Representative elements are the elements that are in the S and P blocks only, or if you're using just the red numbering, it would be 1A through 7A. You'll notice that 8A is not included, and that's because they do not have a lot of chemical properties that they display. So it's groups 1A through 7A for the representative elements. Most of these are solids, but a few are gases at room temperature, and one, bromine, is a liquid. The other liquid is mercury, and it is not a representative element because it's in the transition block. Atoms of representative elements have their S and P sublevels that are being filled, and they may be filled or partially filled. And atoms such as 1A, there's only 1 electron in the highest occupied sublevel, and that is an S level. And so all of the configurations end in S1. Lithium is 2S1, sodium is 3S1, etc. If we look at 4A, the groups from carbon, in the group with carbon, silicon, germanium, there are 4 electrons in the highest occupied energy level. We are filling the P block with 2 electrons, and so we have 2s2, 2p2, which gives us 4 electrons that are in the same energy level. We can also figure out the number of electrons by just counting over, skipping the D block. Periodic table in the B group separate the A groups on the left side from the A groups on the right side, and that B group are called the transition metals, and we are filling the D block when we are talking about the B groups. There are 2 types of transition elements, transition metals and the inner transition metals, which would be the F block, and that's because we're filling F electrons in the inner transition metals. Transition metals are the ones that are displayed on the main group body of the periodic table. These contain many of the common metals we think of: silver, mercury, iron, gold, copper. These atoms are filling in the highest sublevel for S and the nearby D sublevel, which is 1 below. And so if we're filling the 4S, we'd be filling the 3D. If we're filling the 5S, we'd be filling the 4D. So, and so on. These elements are characterized by presence of electrons in D orbitals. Inner transition metals appear below the main group of the periodic table. These atoms are filling the S, and then they fill the F. The inner transition metals are characterized by presence of electrons in F orbitals. And they appear below the main body of the periodic table. Uranium is one example of an inner transition metal. Before scientists knew much about the inner transition metals, they were called the rare earth elements. It is misleading, however, because some of these elements are more abundant than other elements. They're rare just because they were hard to find, not because they're not present in very much. Some of these metals are not found in nature. You'll notice that because they're grayed out on the periodic table, and we won't be talking about these at all. But these were man-made in a laboratory. Blocks of elements, if you consider both the electron configurations, and we've done this, we colored in our periodic tables before. We have the S block, the P block, and those are our main group elements. The D and the F block are our transition metals and intertransition metals. It is divided into sections or blocks. You need to know the names for the 1 and 2A, which 1A is alkali metals, 2A is alkaline earth metals. You need to know the halogens and the noble gases. The P block contains 3A through 8A, with the exception of helium. Intertransition metals are filling the D block and the F block. Each period in the periodic table corresponds to a principal energy level. That's what N is equal, 1 through 7. Suppose an element is located in the third period. Now you know where to look on the periodic table for it. Levels 1 and 2 are filled with electrons. You move across the third period from left to right, and we could find a particular element. I could say it's in the third row of the periodic table and it has 4 electrons. You would go down to the third row, go across 4 elements, and you would find that that would be silicon. If it's located in the third period, for transition elements, electrons are added to the D sublevel, but that's after we've already added to the 4S, and so they are located 1 level below where their number should be. Intertransition levels are 2 below, so the first F is going to the 4F, even though you're filling the 6S. So, use the book on pages in your textbook, figure 6.9 and 6.13, and write the electron configuration for nickel. I think you already know how to do this. We've talked about it. It has 28 electrons, and you should be able to fill it completely. And you'll notice here that they put the 3D with the 3P. I don't care if you put the 3D and then the 4S, or if you put the 4S and then the 3D. Either way works just fine. What does an electron configuration tell you about an element? What does a group tell you? Well, if we know the period, then we know what row it is on the periodic table, and what's the highest occupied level or the principal energy level. And the group will tell us how many electrons are filled into that, if it's an S or a P element, and how many they have. The periodic table usually displays symbols, names of elements, along with information about the structure of their atoms. Elements can be sorted into noble gases, representative elements, transition metals, intertransition metals based on their electron configurations. And our vocab, alkali metal, alkaline earth metal, halogen, noble gas, representative element, transition metal, and intertransition metal. The big idea: periodic table contains each element's name, symbol, atomic number, atomic mass, and number of electrons in each energy level. The electron configuration of element can be determined by its position or location on the periodic table. And that's it. Thanks for listening. I will see you guys in class.